Hi, welcome to PreCalulus Prep Academy, and today we're going to be teaching you guys how to graph polar rose curve equations without a calculator. If you guys find this video useful, make sure you like and subscribe. First, we'll start off with some basic information. So the formula is either going to be a sine n theta or a cosine n theta, and a is equal to the length of the petals or the max in the graph. When n is odd, there's going to be n petals, but when n is even, it's going to be 2 times the amount of n, so 2n petals. When r is a sine function, the first petal is going to start diagonal because sine functions start at the origin and they increase. But when r is a cosine function, it's going to start on the x-axis because cosine functions start on the x-axis. However, that's only when n is greater than or equal to 2. Now let's get into actually graphing the polar rose curve without a calculator. So we're going to do this by finding the zeros, and then the amount of zeros depends on the amount of petals. So it's going to be the amount of petals plus 1, and that's the amount of zeros we need to find. Now we're going to draw what a basic rose curve would look like to show that the amount of times that it goes through the origin is the amount of zeros there are. And as you can see, there's only 3 petals, but there's 4 colors.
So our first example would be r equals 2 sine 4 theta, and we basically set it equal to 0 to find whenever that whole equation equals 0. And to isolate the 4 theta, we do the sine inverse, and then we get the equation 4 theta equals 0 plus n pi. Divide that by 4, which would give us theta equals n pi over 4. And then we plug that into a bunch of other numbers, and we get our zeros as pi over 4, pi over 2, 3 pi over 4, pi, 5 pi over 4, and 3 pi over 2. Also 7 pi over 4, 2 pi, and 9 pi over 4. Also, noting that we need 9 zeros since n equals 4, and it's also an even function. So we get the 9 zeros because there's actually 8 petals, which you get by 2n, so 2 times 4 equals 8. And then you would need 9 zeros. So to actually plot the rose petal, we would need to make a t-table and plug in values for theta into the original equation. So first we did pi over 8, which would give us 2, 3 pi over 8, which would give us negative 2, 5 pi over 8, which would give us positive 2, and 7 pi over 8, which would give us negative 2. And we do pi over 8s because we know that every pi over 4 is 0, so in between that would be pi over 8. And then we draw the circles and 2 because the radius is 2. And then we plot the points and basically scale everything equally. And yes, and don't forget to plot the middle point, which would also count as the 9 zeros. And then you draw all the petals together. And then since we know that there's 8 petals, you can just fill in all the empty spaces. And there's your graph. And in blue, we're just demonstrating that every pi over 4 equals 0, and in between that is when the graph has its maximum amplitude of 2, which would be how long the petal is.
So for example 2, we're going to try an odd cosine function, and that's going to be r equals 3 cosine 5 theta. And so we're going to set the whole thing equal to 0 to find the zeros. And then pretty much we're going to be wanting to isolate theta. So we divide by 3 to get cosine 5 theta. And then inverse cosine of 0 equals 5 theta. And then 5 theta is equal to when the cosine equals 0, which is at pi over 2 plus n pi. We divide by 5 to get theta alone. And then we find that our zeros are at pi tenths plus n pi over 5. And so that gives us our zeros, which are pi over 10, 3 pi over 10, pi over 2, 7 pi over 10, 9 pi over 10, 11, and 11 pi over 10. And so since n equals 5, that's going to be 5 petals because n is odd. And since there was 5 petals, we found 6 zeros. Since we know that there is a 0 at every pi tenths, we're going to scale by pi fifths to find the max points. So at 0, we find that r equals 3, and then at pi over 5, we find that r equals negative 3, because it alternates between the positive and negative a value. And again, a is 3. At 2 pi over 5, we find again that r equals 3. And then at 3 pi over 5, we find that r returns to negative 3. Now we go ahead and use those points to make our graph. We make sure to draw our unit circles so that the petals hit the max. And then we have to estimate about where pi fifths is. And then from there, we just connect the dots. And then this gives us pretty much the first 2 petals. And then we use that to evenly space out the rest of the petals because we know there's going to be 5. And that's our graph. And then we also drew in our zeros at every pi tenths just to illustrate that it's right where the petals return to the pole. Alright, and that concludes our tutorial. Make sure you guys like and subscribe. Thanks!